Hello everyone, my name is Milad Ebrahimi. I'm here with my team member Alfredo Lopez, and we will be taking you through the introduction for VIRS 2.0 Vocabulary in Reading Study. So, one of the major challenges that English language learners as well as the mainstream students face is the lack of the reliable source to improve their academic work. So there is no easy way to validate the easiness of the text, which allows professors to select the appropriate material for class. A challenging text is a wonderful way to propel students forward, yet something too hard to read can cause the opposite effect. With VIRS, we meet these challenges through an easy accessible application and website. As you can see, this is the enhanced text through a color-coded system. So basically, this application allows the user to upload an image, PDF, Microsoft document, or even simple text to website or the web application, and it analyzes the text and it produces a color-coded enhanced text which shows the different category of each words through the different colors, and also it produces the readability score and complete statistic analytic of the text. Here we see the readability level, which it's 39.06. This score is usually between 0 to 100, 0 being the most difficult, and 100 is the most easiest text. And also it tells you about the total number of the sentences, total number of the words, and also the percentage and the number of the different words in different categories. So with this page, it allows professors to select appropriate text and material for English learner students. It also produced word definitions in a pop-up window, so user be able to see the word definition by just clicking on any word, and it shows the definition of the word. And also we have the new frequency-based dictionary that makes it easier for the user to read. So we have like 4 different category: AWL, academic word list, high frequency, medium frequency, and low frequency. And also this web application is completely responsive, and user can access it through desktop, tablets, or any mobile devices. This is our Gantt chart, and these are all the user stories that we did through the semester. And now Alfredo is going to continue the rest of the slides.
Okay, so in here we have the requirement use cases. We see that we have two main users, an admin and a regular user, and an admin can do everything a regular user can do. We can see how to analyze the picture. We need to perform the OCR, and sometimes we get a unparsable content exception there. And after we do the OCR, we can analyze the text, which is going to enhance the text result and calculate the statistics. And for example, in another hand, we have the display word definition, which includes obtains the word and extends like unable to get entry. So for the user story 132 Perform OCR, as a user, I want to see the words and the different categories from an image file so I can know more about the words in the image. So In this little image right here, we see the beginning is the original picture, the one we took with our phone. Then what we do is we using a combination of OpenCV and Tesseract. We convert the image to grayscale, we remove all the colors, and then we apply a threshold with a Gaussian blur. What that's gonna do is gonna give us that bright white background and the sharp contrast with the black letters. And then after that we apply the formatting according to the different categories. So we have the blue colors, the red colors, the golden colors, and so on. So here is the use case um, definition completely. So the preconditions: the user has to desire to know more information about the picture. So the flow of events, the user interacts with the system and chooses a picture, sends the information, the system on the hand receives the information and processes it, and then sends it back to the front end, and the use case ends. And as alternative, the user may receive an unparsable context exception. Here is a sequence diagram for this use case. We have minimized the dependency between all of these systems, so the sequence diagrams are really simple, as you can see here. Uh, in this one we also have the option, the alternative course of actions, which is to send back the error to the user when they cannot parse the content. So in here we have the system design architecture. We are using a model view controller. I think is the best design that we have for this application. So at the base we see the model section in which the repository and the entity interact with the database to get that persistence layer. Then we have the controller controlling all the different aspects of the application, how the user interacts with the application. And in the view we have an Angular 4 application that is being served to the client. This is the system design deployment. We have a server, an Amazon Web Services web service, and here we have a MySQL database, and in the database we have a schema for the word. We deploy the artifact VIRS jar onto the Amazon Web Services, and then we interact with this service using a PC drawer, or we use the iPhone or the Android. Now the iPhone application is in the iTunes Store service, and to get there we need to deploy the iPhone application. Same thing with the Android application. We have an Android APK, and when we deploy that into the Google Store servers, and then we can access it through the Google Store, through the Android device. System design. In here we have the persistent data design. We have a single table that contains all the data, in which there is a word that has an ID, a value, and a category. Pertaining security and privacy, all keys are encrypted using JASIP. We make sure that everything is under control, and so every single property um, that has to be uploaded onto the repository on GitHub is encrypted, and that way we maintain it secure. We have an environment variable that has to be set with the secret, so then we can decrypt those properties. Yes. Also, to access all the APIs of for the application, we use Swagger, and the Swagger endpoints are also secured. This is the minimal class diagram for the frontend. Basically, it's an Angular 4 application. We are using TypeScript, so we can see the different classes, a service, and interfaces used to build our application. And this is the minimal class diagram for the backend. We have different entities that are gonna be persisted, actually one single entity that is persisted to the database, which is the word. We also have different processing services that are implementations of interfaces, realization of interfaces. This allows our system to be loosely coupled, so we can actually um, change those services as we go along if we have to, and we don't have them tightly bound to the application. In here we have the main algorithm for the application. We have a list of words and we have a result map, and then we are going to loop through each one of the words, and then we're gonna get a clean word. A clean word is a word in which we'll remove anything that has to do with probably punctuation, might be, or we clean anything that has to do with plurals. So we basically get the lemma of the word without any inflection. Um, then we check against the result map, and the result map is a little bit of a small cache, so allows us to cache the results as we go along, and we don't have to go to the database again and search for the word. So if the result map contains the word, just add it to my final word lists. If the word is not found, then go ahead and go to the database and try to find that word, then add it to the map, and then add it to the list. And then we just repeat this for every single word. Test suites and test cases. JUnit was the main tool utilized to verify our system. We implemented several integration tests that are run before deploying to the web. That way we ensure that the system is working correctly. In the front end, we use Karma and Jasmine to perform unit testing for the front end, and Compodoc and Istanbul were used to generate the code coverage report in the front end. One of these test cases, we have a get flash reading each with data from the website returns 60. And we are getting the flash reading score for a word count of 300, and a sentence count of 12, and a syllable count of 430. And we need to make sure that this returns 60.2. There is no preconditions for it, and then the expecting result reading score was 60.20, and so our status of the test is a pass. On the other hand, for the front end, we have a test case ID. Test components should be created. The test component should be created is the description. The server must be running as a precondition. The expected result test components should be created, and the actual result was that the text component was created, giving us a status of pass. So, in summary, VIRS is a web application that facilitates the learning of new languages through the analysis of the text and gathering of data displayed to the user in a very intuitive way. Data given to the user includes a category for each word as far as how popular they are, and gives the definition for the words in the text so the user can inspect it further. It will also provide a user with a complete statistical text analysis report and readability score. So this is our presentation. Thanks a lot for watching. This is Alfredo and Milad. Goodbye.
Goodbye. Thank you.